We are getting ever closer to that last axiom for the real numbers. But before we get there, we got to talk about the concepts of upper bounds and lower bounds. And the intervals that we were talking about in the last video are going to help us have that conversation. So first, we're going to list different types of intervals to give you an idea of what they look like. We're going to make some observations of what the endpoints of the intervals are and what different ways of describing them. We are going to define the concepts of lower bounds and upper bounds of sets of real numbers. And then we're going to apply that definition to an interval. And then finally, we're going to look at a concrete model for lower and upper bounds to help you understand them and be able to apply them. So here's a list of all types of intervals. Now, most of these you're going to be looking at in a portfolio problem. Not all of them, not the unbounded ones, but you'll be proving this later, so I'm not going to prove that here. So the open interval AB, the closed interval AB, then the two half open, half closed intervals. You can have it open on the left and closed on the right, closed on the left and open on the right. You can have them unbounded in different ways. You can have unbounded below, so any number below B. You can have the closed interval bounded at or below B. Then you can do the same thing with above A and at or above A as well. And then finally, you can have the very unbounded interval of all the real numbers, which you could look at as the interval from negative infinity to infinity. At least it's a reasonable notation for it. Now, the one thing you might ask is, A and B sort of play a pivotal role in all of these intervals. What's a mathematically precise way of describing those numbers? One thing you may notice is that the number A is less than or equal to every number in the interval in all of the intervals where it appears. And it turns out that makes A a lower bound of the interval. And the number B is greater than or equal to every number in the interval, and that makes B an upper bound of the interval. And so that leads us to the definition of lower bounds and upper bounds. So let S be a subset of R. We say that a real number alpha is a lower bound of S if alpha is less than or equal to X for all X in the set. And we say that a real number beta is an upper bound of S if beta is greater than or equal to every element of S. And I should note that that applies to intervals like we were looking at before, but the set S can literally be any set of real numbers. So let's go ahead and look at intervals anyway. If we look at the interval 1, 7, that's open on the left, closed on the right, we know that every element of that interval is greater than 1. That makes 1 a lower bound of 1, 7. And we know that every number in the interval is less than or equal to 7, and so that makes 7 an upper bound. However, and this is a very small issue, but there isn't just one lower bound of the set. The number 0 is also a lower bound. 0 is less than or equal to all the numbers in the interval. So 0 is also a lower bound. And for instance, the number 47 is also an upper bound. So 7 isn't the only upper bound. So there are tons and tons of lower bounds and upper bounds of this interval. So the lower and upper bounds by themselves do not uniquely tell us what the endpoints are. So that's something that we're going to have to think about later. Alright, so before I leave you in this video, I do want to give you at least one model to help you understand understand lower and upper bounds. And I think of it as the containment model. An upper or a lower bound of a set S of real numbers is a number that doesn't let any of the numbers get past it. So if it's an upper bound, it doesn't let any of the numbers get past it above it. If it's a lower bound, it doesn't let any of the numbers get past it below it. So I think, so if B is an upper bound, that means no numbers in S can get higher. If it's a lower bound, that means no numbers in S can get lower. So I think about the old days when we were herding children through a crowded walkway. I would be in the back, right? The children are the set. I would be in the back, not letting them get past me, and then their mom would be in the front. They wouldn't get past her. So she and I were the upper and lower bounds of that set of children in the set. So we think of keeping the children from getting lost. That we are the upper and lower bound for that. Containment of a fire is a good image as well. Not a very nice image sometimes, if it can be a destructive fire. The fire is the set. You want to make sure that there are bounds outside the fire to keep the fire from getting out of control. If you're a fan of football, the free safety is make sure to keep the receivers in containment. The receivers are the set, and then the free safety doesn't let the receivers get behind them. And so there's all sorts of metaphors that you can use for that. Those are three that I kind of like. So now I think you're ready to look at the activities for lower and upper bounds of some different sets, not just intervals. Go ahead and go to the link below this video.